Hi guys, welcome to the factor label tutorial. Before we get into how to do this method called the factor label method, I just want to introduce you to a couple of basic ideas. Let's start with this. I've written several fractions on this screen, and what I want you to do is ask yourself this question. What do they all have in common? Well, what they all have in common is that they all equal 1. 4 divided by 4 is 1. 10 divided by 10 is 1. 12 divided by a dozen is 1, because 12 and a dozen are the same number. 2,000 pounds divided by 1 ton is also equal to 1. That's because there are 2,000 pounds in every ton. And 100 cents and $1 are also equal to each other. So if you divide that by that, you'll get 1 as well. So these fractions are called conversion factors. At least the bottom two and the one on the right on the top are all conversion factors. They're fractions or ratios really, or proportions, that show you that two things are equal to each other. If you divide one by the other, you're going to get 1. You could write all of them upside down. In other words, I could say a dozen on top and 12 on the bottom. And I could do the same thing with the 2,000 pounds and the ton. I could flip it. I could flip the cents and the dollar. This technique of creating a fraction that represents a ratio between two different things that are equal to each other is a topic that you need to understand in order to do factor label. So let's try it out. Okay, so we're going to create some conversion factors, but before we do, we need to talk about the units that we use in the metric system. So in the metric system, we have 3 base units. The mass unit is the gram. The volume unit is the liter, and the distance unit is the meter. And then the beauty of the metric system is you can break the gram into smaller pieces, or you can make larger mass units. All you have to do is add a prefix. And here are the prefixes: kilo, hecto, deca, deci, centi, and milli. Kilo means 1,000. Hecto means 100. Deca means 10. Deci means 1/10. Centi means 1/100th. And milli means 1/1000th. Oops, 1/1000. A little bit awkward, but I tried to do it. So what does that mean? Well, that means that a kilogram is 1,000 grams. A hectogram is 100 grams. A decagram is 10 grams. A decigram is 1/10 of a gram, which is the same as 0.01 grams. A centigram is 0.0. As I was saying, a centigram is 0.01 grams, and a milligram is 0.001 grams. So the same prefixes are used with the liter. A kiloliter is how many liters? 1,000. A deciliter is what part of a liter? It's 1/10 or 0.1 liters, and so on. So all you have to know is what the prefixes mean, and then you can attach them to any base unit you want to. Before we move on from this screen, what you want to do is you want to make sure that if you see the word decameter or the word deciliter or the word centigram, that you know what that means. So take a minute, write down what all of these different prefixes mean, and you can refer to it while you're practicing, because you're going to need to until you can kind of get past the training wheels stage, right? You're on training wheels right now. You need to use your cheat sheet. But after you've practiced enough, you probably won't need to. Okay, so get that cheat sheet ready so that you can do the problems that come next. You have to have it, because otherwise you're going to have to keep referring back to this particular screen, and that's going to annoy you. So pause it, copy it down, and then move on to the next screen. Okay, we're going to make some metric conversion factors. Remember what a conversion factor looks like. Here, I'll do one for something you know, right? If I wanted to make a conversion factor for the relationship between minutes and hours, here's what it would look like. I'd do 60 minutes over 1 hour. Alternatively, I could write it as 1 hour over 60 minutes. They're the same thing. So that's what a conversion factor looks like. Okay, can you create the conversion factor that shows the relationship between grams and kilograms? Pause the tutorial, see if you can do it, and then see what I came up with. What's the relationship between grams and kilograms? So grams and kilograms, or kilograms and grams. What's their relationship? Well, 1 kilogram has 1,000 grams, because kilo means 1,000, which means if we were writing it the other way, it would look like this. So far, so good? All right, let's try another one. Create a conversion factor for the relationship between liters and deciliters. Liters and deciliters. So liters, the abbreviation for the word liter is capital L, and the abbreviation for deciliters is little d capital L. And that's important because decaliters would be capital D capital L. And that's because deca, you can think of the capital letter goes with the bigger unit, right? Deca is for 10. Deci means 1/10. So what is the relationship? Well, 1 liter has how many deciliters in it? Well, deci means 1/10. So, did you guess right? There's 10 deciliters in a liter, right? Because a deciliter is 1/10 of a liter, which means there has to be 10 of them to make up 1 total liter, right? If something is 1/10 of the whole, don't you need 10 of them to make a whole, right? If I give you a candy bar and I break it into 10 equal pieces and I give you 1/10 of the candy bar, you're going to need 10 of those pieces to make the whole candy bar again, right? So a deciliter is 1/10 of a liter. That means there must be 10 of them in the liter. Okay, so you see kind of how to do this, right? Now, I've shown you that you can do them in either direction. You know, each one of them can be 60 over 1 or 1 over 60. 1,000 over 1 or 1 over 1,000. Oh, look, missing the 0 on my grams. I can't have that. Go grab that color. Here we go, 1,000 grams, sorry. And then same thing here, right? We have 1 over 10 or 10 over 1. Same thing, though, because remember, we're trying to make a fraction that's equal to 1. All right, now let's actually use this in the factor labor method. Okay, here's our first practice problem. How many centimeters are in 523 meters? Let's set up a factor label way of doing this. Here's what you do. You take the number you're given, which is 523 meters, and you write it with the units. 523 meters. It helps to abbreviate. Then what you want to do is you want to multiply that number by a conversion factor that will get rid of meters by making you able to cancel units. So I'm going to want to put meters on the bottom of my conversion factor. And on the top, I'm going to put centimeters because I'm looking to convert to centimeters. So in the end, this is what I'm looking for. I'm looking to be able to cancel this meters with this meters and be left with the unit centimeters. After all, that's what I'm trying to find out, right? I'm trying to find out how many centimeters I have. So the only thing left to do is to come up with the right conversion factor. What's the relationship between meters and centimeters? Well, 1 meter contains 100 centimeters because centi means 1/100th. So there's 100 centimeters in 1 meter. Now I can actually just multiply. 100 times 523 will give me 52300, and I've kind of run out of room, but my units now are centimeters. Divided by 1 is just going to give me 1 again. So, ta-da, 523 meters contain 52,300 centimeters. Now, some people can do this kind of thing in their head. Some people just say, oh, I just need to multiply by 1,000, and that's, or multiply by 100, I should say. And that's okay. You can do that. You can just multiply by 100 when you're doing a simple problem like this. But the problems are going to get more complex. So I require this is required, it's not optional, I require that you learn how to do this method. And when I do test you on it, and I will, you will be required to show all the work that you see here in order to get full credit. Okay, I'm going to give you another problem right underneath this one that I want you to try. We're going to do one where the conversion factor should be something you automatically know. So try this one. See if you can set it up just like I did. Go ahead and pause the tutorial and write down the work that shows how you would get from 214 minutes to the number of hours. See if you can make it look just like mine, and when you're ready, you can check your work by continuing the tutorial. Okay, this is how I'm setting it up. 214 minutes is what I started with, times a conversion factor that converts between hours and minutes. I know there's 1 hour in 60 minutes. So now minutes cancel with minutes, leaving me with hours. That's where I'm trying to go. When I multiply across, I get 214 hours divided by 60. And I'd have to break out my calculator for this. And my calculator said 3.56 repeating was the answer. But I rounded that to 3.57 hours because I'm only allowed to have 3 sig figs because that's what I started with. You might be thinking that I should only get 1 sig fig because there's only 1 in 1 hour, but you don't count conversion factors in your sig fig calculations because these are exact numbers. They're not measured numbers. This is the measured number. That's what we have to worry about. So our number of sig figs matches that. Obviously, it takes a lot of practice before you get good at this. And some people have had the opportunity to practice in their math class. Other people, this is the first time you've ever seen it. So everybody needs to go at their own pace through this. So I'm going to give you lots of problems to practice. And as you practice, you'll get better and better. Here's what I want to tell you, though. For Monday, for your quiz on Monday, the only thing I want you to be able to do is tell me the relationships among all the different metric units. So I want you to just take the weekend and memorize them. Let's go back to that screen. Okay, so as you're figuring this out, here's what you want to do. You want to remember what each prefix means, number-wise. You want to know the 3 base units, the gram, the liter, and the meter. And here's how I'll ask the questions on the quiz. I'll say, write a conversion factor that shows the relationship between kilometers and meters. Or write a conversion factor that shows the relationship between centiliters and decaliters. That one's a hard one. Basically, so what you would have to do is you need to figure out how many there are of each of these things in the base unit. You'll always be able to go through the base unit. So the base units are grams, liters, and meters. So there's 1,000 grams in a kilogram. There's 100 grams in a hectogram, and so on. So figure that out, get that memorized. Probably just memorizing this list will help you. And then you'll be able to take that quiz on Monday. Okay? And if you get really, really stuck on the quiz on Monday, I might help you out with this little mnemonic. I might write those on the board just to remind you what order they go in. And also keep in mind, deca and deci, you distinguish between them by using the capital D and the lowercase d. The capital D goes with the one that has a higher value. Okay, I think that's enough to worry about over the weekend, and I will see you guys on Monday.